Howdy Huskies, we're going to go ahead and do day 10 today, which is solving right triangles. The goal of today is to find all the angles and all the sides of a triangle. So we're going to use this little graphic organizer to get it started. So if we need to find a side, and this keyword is our side first, we pretty much have two options. Our first one is going to be our regular trig. And when I say regular trig, that means we're going to go ahead and use our regular old SOHCAHTOA. So that would be our regular sine, cosine, and tangent. And that's a little bit different from the inverse that we've just been talking about. And then the second thing that we have is good old Pythagorean. So if we need to find a side, those are kind of our two options that we're going to go ahead and be able to use. Our regular trig functions and our Pythagorean. Now, if we need to find an angle, which is this other one here, friends, that's our options is that we have our inverse trig. Now that's still our SOHCAHTOA, but sometimes we want to go ahead and put that little -1 to remind us that we're finding the angles up there, okay? And the second thing that we have is that there's 180 degrees in a triangle, okay? So those are going to be our two options to help us find angles of a triangle. So we have sides and we have angles today. So if we take a look at this little diagram down here, we notice that we have three things. We have a little 90-degree box, so we know what B is. So I'm going to go ahead and say that angle, I think there's supposed to be a little angle in there. So that is ABC. So ABC is 90 degrees. And then we can clearly see that we have a 4 here and a 9 there. So AC is 9. And then we have BC is 4. So we need to find one more side. And so I'm going to put an X right there. And then we're going to have to find two angles. So I'll go Y and Z. Now, it doesn't matter where you put X or where you put Y and where you put Z. But ladies and gentlemen, that's our plan. So I'm going to go ahead and do the side first because there's only one of those. So what I notice is if I have two sides, that really helps to do our little A squared plus B squared equals C squared because we don't need any trig. So we know that this is going to be my hypo. So my 9 is going to be the 9 or the C. And then it doesn't matter which one is which. So this 4 over here looks pretty small. So I'm going to call this my A. So I have 4 squared plus X squared. Alrighty. So we're going to go ahead and get 16 plus X squared is equal to 81. And then when I go ahead and I subtract over that 16, we're going to go and get 65. So X squared is equal to 65. And remember that this is X squared. It's not just X. So we need to take the square root of both sides. Now, this breaks down into 5 and 13. So it's actually totally okay for us to leave this at root 65. Now, most of us don't like to go ahead and leave it as that because, we're not quite sure what number that is. So if you want to go ahead and rewrite that as, I'll say, or 8.06 is what my calculator is going to say. That's okay too. So either one of those, I'll go ahead and highlight those in yellow here, are totally okay. And you would get them completely right. Now, if I were to say which one you're probably going to see more, it's going to be that one with the radical, because when you see these on stuff like district finals or ACTs, and they really want you to be able to do some stuff without a calculator, so they'll probably leave it in that form. All right, so two angles left. So I'm going to pick one. I'm going to go ahead and pick Y. So if Y is my theta now, so I'll go ahead and just remake it my theta. So that means this is going to be the opposite side, and this is going to be the adjacent side. So I'm going to go ahead and say alrighty. So if I do SOHCAHTOA, and really these are the inverse ones, so I'm going to put my -1 there because I'm looking for an angle. Notice I have information, if I zoom in on my diagram here, about my opposite side and my hypo. So I'm really looking for which trig function goes O and H. So O and H is going to be our sine. So we're going to do our inverse sine. So inverse sine of opposite over hypo is going to give us our angle. So in this case, that's the measure of angle A or Y. So let's plug in our information. So sine inverse of 4 divided by 9 is going to give us what y is. And if we go ahead and put that into our calculator, 4 divided by 9, I'm going to get 26. Y is equal to 26 point, we'll go 39 degrees. Cool with that? Now, some of you are wondering how we do that because you missed that video. I'll go ahead and get my calculator out here. So right here, you see the sign button, and then right above it, you see inverse sign with the -1. So I do second sine, then 4 divided by 9, close my parentheses, and there we go. Okay, and then we obviously do some rounding. All right, so back over here. So I'm going to write that down. So y, which was angle BAC, is going to be 26.39 degrees. So how do we find that last angle Z? Well, you could do your trig again, absolutely, but I'm a fan of 180 degrees in a triangle. So I know I have a 90-degree box plus the 26.39 that I just found plus angle Z is going to equal 180 degrees. Cool with that? So then I'm going to go ahead and solve for Z. So when I go ahead and do so, 26.39, putting that in my calculator off to the side here, I'm going to get Z is equal to 63.61 degrees. And that's all it is to it. So really it is taking all of our pieces and putting them together to solve all of our right triangle information. All right, let's go to our next one here. So we have 2 more here for us to try, and then we're done for the day. So on this one, I'm going to go ahead and have to find another side. So I'll put an X here, and then angle R, and then angle T. Okay, so I'm going to go ahead and start with Pythagorean Theorem again. So a squared plus b squared equals c squared. And I'm doing that because I have 2 sides here with that 8 and the 11, and it really leads itself to a Pythagorean Theorem situation. So 8 squared plus 11 squared is equal to x squared. So that'll be 64 plus 121 is equal to x squared. So that's going to be 185. Let me double check that for 64 plus 121 on my calculator here. Yep, 185 is equal to x squared. Now I'm going to go ahead and take the square root of both sides. And when I break down that, I get 5 and 37. We don't get any ones that are breaking down for no reason. So we're going to call x is going to be either the square root of 185, or if we want to go ahead and do that 185 and find out what that is, that's going to be, as a decimal, 13.60. Okay. Well, it's 601, but we'll call it 60. So let's write down that information for my sides. So RS is 8, then we had ST was 11, and then we just found out that this is going to be 13.60. All right. Now we have to find what our 90-degree box is. That's going to be S, so that makes it pretty easy. So we'll put 90 degrees right there. So R and T. So to find one of the angles, we have to use our inverse trig. So let's go ahead and find Z this time, just to mix it up. So I'm going to do so, ka, toa, and I'm doing those -1s because we're doing the inverse. So that means this is the hypo. Let's do that in a different color. Hypo. And then this is going to be the opposite side, and this is the adjacent side. So if I look at this, I am looking for opposite and adjacent. That's going to be perfect for tangent. So tangent inverse is going to be the opposite. That's what the O is. Over the adjacent, that's what the A is. And that's equal to our theta that we're looking for. So in this case, we're going to say tangent inverse of 8 divided by 11 is going to give us Z. So this is a calculator one, so we'll go ahead and do inverse tangent of 8 divided by 11, and we're going to get 36.03 degrees after some rounding. Alrighty, so now similarly, friends, we're going to go ahead and just say let's tackle that last angle. So we're going to do 180 degrees in our triangle. So 180 is equal to the 90 from S, the 36 from Z, and then plus Y. So when we go ahead and we figure out all that loveliness with our calculator, we're going to go ahead and have Y is equal to 53.97 degrees. So let's finish this up. So T was that 36.03, and then R was at 53.97 degrees. So pretty easy peasy. We're gonna let you try one. So if you're watching this at home, friends, we want you to hit pause and then see if you got the same answers that we're gonna have when we come all back. It's a little bit different, but I believe you guys got this. All right, hopefully you hit pause here, friends. But we're looking for a side X, a side Y, and this angle Z. You could mix up those letters, it doesn't matter. But in this case, I'm actually gonna find the angles first. And the reason is I only have one angle to find, and that's going to be kind of easy. So 180 degrees in a triangle, so 180 is equal to that 90 degree box, the 28 plus Z. So when I go ahead and I do my mathiness here, I solve that equation, Z, that last angle is going to be 62 degrees. All right, nice and easy. So then we got to find X and Y. So I'm actually going to make this my theta because that's the angle they gave me. It just makes it a little bit easier in case I made a mistake somewhere. So I'm going to use my regular SOHCAHTOA here, friends. And the reason is we're looking for sides. So that means that this is going to be the hypo, as it always is. Y is going to be the opposite, and this is going to be the adjacent. So if we take a look at this, opposite over adjacent would be y over x, which is tangent because it's opposite over adjacent. So that's the only trig function one we can't use. So I'm going to have to use both of my sine and my cosine. So let's use our sine first. So sine of some theta is going to be equal to the opposite over the hypo. And I'm going to make that over 1 because I'm going to cross multiply. So the sine of 28 degrees over 1 is equal to the opposite, which is y, over 14. So, and hopefully we've been doing this in your classes here, friends, but I like to find out what the sine of already is right off the bat. So this sine 28, we just put that into the calculator. So just so you can see what that is, it's going to be a decimal. But we just do sine 28. Notice that's regular sine because we're finding the side. And I get that 0.4694. So I go 3 decimals. That's my kind of magic number for sides. And so I look at that 4, and since that 4 is under 5, I'm just going to leave it as is. I'm not going to round up. So this is going to go ahead and become 0.469 over 1 is equal to y over 14. And then we're just going to cross multiply. So 1 times y. So 1 times y is going to be just y. And then on this other side here, keep picking colors I've already used. I'm going to get 14 times that decimal of 0.469. And so when I put that into the calculator, we're going to get 6.57. And it says, looks like 57, and I can round up for, so 573. Cool with that? Alrighty. So now you could do the Pythagorean theorem if you want to. I'm just going to use another trig function. So here we know we're going to use cosine of some theta is going to be adjacent over hypo. And we'll do the same thing. We're going to do our cosine over 1. So I'm still going to use that 28. So cosine of 28 over 1 is going to be the adjacent, which is x, over 14. So in this case, I'm going to do the cosine of 28 and find out what that decimal is. It is 0.883 over 1 is equal to x over 14. So now we're going to do the same cross multiplying. So 1 times x is going to be just x. And then this way, we're going to get 14 times 0.883 And that's going to go ahead and give us 12.361. And now we're done here, friends. We found our angle Z. We can fill out our table. We found our two sides, so we're good there. And that's going to be it for today. A nice, easy video. Hopefully this is helpful, really bringing everything all together. Friends, we'll